Hello everyone and welcome back to another video. It has been some time since our last one, mainly because I've been busy with all my IBIAs and whatnot, and with winter break and living, but we are back. We're going to skip over 2 units, Unit 2 and Unit 3. Yeah, maybe I'll come back to them, probably not, but today we're doing exercise 4E. Looks like this exercise is all about gradients and slopes, so let's go ahead and start. Question 1 gives us a function, y equals 2x squared plus 1, and it asks us to find the gradient at the point x equals negative 1. Okay, to find the gradient, we first have to find the derivative, because the derivative gives us the tangent line, which is this. And here we can plug in negative 1 at that gradient, which is negative 4, and that is our answer. Just like that, super easy to find the gradient. Okay, 1b, we have y is equal to 1 minus 3x squared at x equals 1. Okay, once again, y prime is just going to be equal to negative, 6x, and negative 6x times 1 is obviously negative 6. That is our answer. Okay, on to C. We have y, or not C, well, yeah. On C, we have y is equal to 2 divided by x at x is going to be equal to negative 1. Let me fix that up a bit. Okay. For this, we can just use the power rule once again. Rewrite this as y is going to be equal to 2 to the x to the negative 1. So in that case, we have y prime is going to be equal to negative 2 now, because this negative 1 comes up here, times x to the negative 2, which is just going to be the denominator at, what was it asking again? Oh yeah, at the x equals negative 1, so we can plug this in, and that gives us negative 2 as our answer. Okay. On to 1d, we have y is going to be equal to negative x squared at x equals negative 1, right? Yes, okay, even easier. Once again, power roll this. And we get our answer of 2. Now, look, this is going to be a short video, hopefully. It's nighttime and I'm sleepy. Okay, so we have y equals x cubed. Once again, looks like exercise 1 is just super easy. Once again, power roll this baby and we get 3x squared, which is just going to be, 3, that's not a 3. Wow. I'm just going to do this because it looks cooler, which is equal to 3. Next we have y is equal to x squared. Dang, that's rough. Plus x at, oh, there's more. Minus 1 at x equals 0. Ignore the horrible handwriting. I don't know what's going on. Okay, what is going on with this? Okay, 2x plus 1. And the x equals 0, we're just going to get 1. Okay, 1g. What is going on, dude? Is it because my battery's low? Hope not. Okay, we have 1 divided by x squared. And we need to find that x equals 2. Okay, remember we can just rewrite this as x to the negative 2. Using the power rule, we're going to get negative 2, x to the negative 3, which is then going to be equal to negative 2 divided by 2 to the 3, which is negative, what is that, 2 to the Frick. Negative 2. Wait, why am I like forgetting how to do math? What the heck? 2, 4, 8. Yeah, okay. Oh my god, jeez. Okay, and that's just negative 1 over 4. I was trying to like simplify it, but whatever. Okay, on to the last one. On 1, we have 1h. Can't, okay, I'm just gonna start writing like this. We have y is equal to x divided by x plus 1 at x equals 0. Okay, geez, okay, for this we're gonna have to use the quotient rule, which says that take the derivative of u, which in this case is going to be x, which is going to be 1, multiply it by the denominator, x plus 1, minus, and then now x, and now, in this case we have u and v here. Please work, okay. And the derivative of the bottom, which is also just 1 in this case, all over x plus 1 squared. And now this just simplifies to 1 divided by x plus 1 squared, and it asks at x equals 0. So now we're going to get 1 divided by 1 squared, which is simply just 1. And that finishes up that exercise. So let's go on to 2. Okay, 2 says that A and B are 2 points on a graph, which, and this graph is f of x is equal to x squared plus 3. The x coordinate of A is 1. And we're just going to say A. And then the x coordinate of B is 1 plus h. That is not h. B. Find in terms of h the gradient of the secant line AB. Hence deduce the gradient of the tangent to the f of x at A. Okay, wow, confusing for no reason. But that's fine. Okay, so let's go ahead. And first, let's see, let me actually think of what I need to do here. Wow, the secant gradient. Am I losing something? Oh, these are coordinates on the graph already. Oh, whoops. Okay. So we know that F1, so let's just go ahead and plug this in so we can find A and B. I thought that was talking about like in its gradient line. Okay, no, these are coordinates on this graph. That helps. F1 is going to be equal to 1 squared plus 3, which is equal to 4. So that means A is equal to 4. And we have f of 1 plus h work. And that's going to be equal to 1 plus h squared. Please work. Plus 3. And that's just all equal to, once you simplify that, let's see, 4 plus 2h plus h squared. Okay, and the equation for the secant gradient, I had to search this up actually, because I forgot what it was. Deduce the gradient of the secant, find in terms of h the gradient of the secant. Yeah, I had to actually search this up. It's going to be this first, what is it called? I'm losing it. F of x value, or yeah, this first x value minus this first x value over h. So f of 1 plus h minus f of 1 divided by h. Okay, low battery, wow. So now we have 4 plus 2h plus h squared plus 4. Oh, whoops, that should be a minus 4. Minus 4 divided by h. That ends up simplifying to 2h plus h squared divided by h, which is just equal to 2. 2 plus h. Okay. And that was, as we said, the secant gradients, which means that what it's asking, hence it is the gradient of the tangent. Okay. We know that the tangent gradient is going to be the limit. Oh my God, please work. Limit as h approaches 0 on the secant gradient, which in this case is 2 plus h, which means that that is 2. And that is our answer. And yep, that's all. And if you want to actually fact check this, we can go all the way back over here where our function was f of x is equal to x squared plus 3. F prime of x is going to be 2x. And that x equals 1, as we said earlier, it's 2. Okay, that's just the proof for that. On to number 3. Okay, 3a says, by using the fact that any gradient of a curve y equals f of x. Okay, it's just giving us the limit definition. Limit as h, which is what we did last time. I'm just going to write this down real quick. Yeah, the gradient of any curve is equal to this, which is what we did over here whenever we were doing that. We were doing the secant gradient though. Okay, it's asking us to find the gradient of the function 3x squared plus 2x minus 1. Okay, usually we would just do the power rule here, but since they don't want us to do that, can we use the power rule here? Oh, I guess they don't want us to. Yeah, okay, typically I would just use the power rule here. Okay, well, let's evaluate this function first at f of a plus h. A plus h squared plus 2, a plus h minus 1. That's going to be equal to 3a squared plus 6ah plus h squared. Wow, this handwriting is horrible. I feel bad for anyone that's actually using this video. Plus 2a plus 2h. The reason why we're doing this once again is so we can get this. We know what this is. That's just going to be literally when we plug a into it like that. We need to find what that is. And that's going to be 3a squared. Where did I mess up? Nowhere yet. Okay. Plus 6ah. Well, that's what it is. I can't simplify it any further. Minus 1. Almost forgot about that. Okay. Well, let's bring that up here. So now we're going to have the limit as h approaches 0. Over here we have 3a squared, man, this is gonna be a lot of work, plus 6ah plus h squared plus 2a plus 2h minus 1. And now minus, we're going to plug x in for a in this original equation to get 3a squared minus 2a and minus 1, so plus 1. Okay, now we start canceling out terms. Oh, that divided by h. Okay, so this cancels out, that cancels out. What else? This cancels, that cancels, that cancels, that cancels. So we're going to get the limit as h approaches 0 of 6ah plus h squared divided by h. Hey, look at that. That divides pretty nicely. So we get 6a. Wow, that's not working. Wow, I think I did my math wrong. Oh, wait. I forgot about the 2h. Oh my god. Wow, that would have been crazy. That's where my math went wrong. Okay, I forgot about this 2h right here. And once we can simplify this even further by dividing everything by h to get 6a plus h plus 2. And as the limit approaches 0, we get 6a plus 0 plus 2, which gives our final derivative of 6a plus 2, which is the gradient of the curve. Remember that a equals x. And if we come back over here, if we power rule this, we're going to get 6x plus 2. Look at that, 6a plus 2. And that's how you solve it using the limit definition. Okay, on to 3b. Hence, find the coordinates of the point on the curve where the gradient is -4. Okay, easy. We said that the gradient earlier was 6x plus 2, right? Yep, plus 2. And it's asking us to find the coordinates of the point on the curve where the gradient is -4. Okay. In that case, we have to set it to -4 instead of plugging x equals -4. Solving this, we get x is equal to -1. So that gives us our first coordinate. Then we go back to the original. The reason why we're not plugging it, okay, the reason why it's going to be like this, sure, I need to explain this a bit more. It's asking us to find the coordinates on the point on the curve, so the original curve, where the slope is -4. This is the slope equation here, so we're going to set the gradient or the slope to -4 to get our first x coordinate. And at that coordinate in the original function, let that equal f of x. In the original function, that's going to be our y value. Right now, we have our x value of -1. So plugging this back into the original equation, we did not get 6. We get 3. Where did my thing go? Oh yeah, -1 squared plus 2. Wow, this thing is not working. I've said that a lot today. Please. 2, -1. What was that? A -1 at the end? Yep, -1, which is going to be 3 minus 2 minus 1, which is literally just 0. So that gives our y value at 0, and this is our solution. Okay, on to the last one, number 4. So to find the coordinates of the point on the graph of y equals, I'm just going to set it like this for now. That's not even that. 1 divided by x squared, or x to the -2, where the gradient or the slope is -1/4. Okay. First, we need to find the equation of the slope. So y prime, remember power rule and goal is we're going to get -2 divided by x cubed, which we actually showed earlier. And we know that the slope is equal to -1/4, which means that x cubed is going to be equal to, what do we do here? Oh, sorry, 1 divided by x cubed is going to be equal to, divide everything by -2, so we should get 1 divided by 8, which means that x cubed is going to be equal to 8, so x is equal to the cube root of 8, which is 2. So that gives our first coordinate of x equals 2. And remember what we said earlier with 3b, we have to go back to the original function here and plug that in. So we have y is equal to 2, the -2, which means that y is equal to 1 divided by 4. And that gives our final point of 2 and 1 divided by 4. And that is our answer. And that's going to be all for today's video. I hope that helped. Quick lesson back if some of this was confusing. Actually, I have no clue where my other stuff is, so I have no clue where my work went. Okay, wow. Yeah. I need to remember is the limit definition. Knowing that the gradient of a graph of the function is to find its derivative, and then just set equal to whatever x value is given to you. Recognize that the gradient of the secant line AB, when that limit of that is approaching 0, that's going to give your tangent. And that's about all. See you all next time.